Welcome to Homework Lib.
Hi, so in this case we're going to have the titration of a strong acid with a strong base. So let's calculate the values following the different points of the titration of 20 milliliters of zero point 0.1 molar HCl with zero point 0.1 molar of KOH. Okay, so the first option that we're going to have is that no KOH is added. Thus, the pH is only going to depend on our initial solution, so since this is a strong acid, this becomes minus the logarithm of the concentration of H+. In this case, the concentration of H+, is equal to the concentration of the HCl, so this is minus logarithm of 0.1, which it is going to give us a pH equal to 1. Now, for the second step, we add 10 milliliters of KOH. With this, we know that the total amount of mole of OH minus that is being added to the solution, it is going to be that volume, 10 milliliters, times the concentration of KOH that we have. But we need to transform those 10 milliliters into liters. So how do we do that? Simply using a conversion factor, 1000 milliliters correspond to 1 liter. I'm going to put it right here. Okay, so the amount of mole of OH minus that is added, it is going to be equal to 1 times 10 to the minus 3 mole of OH minus. We also know that comparing the volumes that we have and considering that the concentrations are the same, we know that this is going to be exactly 1/2 of the amount of the moles of HCl that we have. Just for proving that, let's do the same procedure. Let's calculate the amount of hydronium ions that is going to be generated, which is the same, that is started in our solution, which is going to be 20 milliliters times our conversion factor, 1 liter, 1000 milliliters, times the concentration of the solution that we have of HCl. Okay. So this tells us that the amount of H3O plus that we are going to begin with in the solution is going to be 2 times 10 to the minus 3 mole of H plus. Now for case A, this means that all of the OH minus will react with H3O plus. So we're going to end up with 1 times 10 to the minus 3 and mole of H3O plus. If you want to follow this using a nice table, we can set up the reaction of H3O plus OH minus producing water. At the beginning, we're going to have 2 times 10 to the minus 3. We're going to add up 1 times 10 to the minus 3. OH minus is the limiting reagent, so the change it is going to be 1 times 10 to the minus 3. This water is liquid, so we don't take that into account. And at equilibrium, we're going to end up with 1 times 10 to the minus 3 and something close to 0. So with that amount of mole, we can calculate the concentration of H3O plus, which is going to be N H3O plus divided by the final volume, which is 1 times 10 to the minus 3 mole divided by the final volume, that it is going to be 30 milliliters, or 30 times 10 to the minus 3 liters. Thus, the concentration of H3O plus, after we have added 10 milliliters of the other solution, it is going to be 0.033, which corresponds to a pH of 1.47, 47.7. Okay. Next up, in part C, we're going to add is 20 milliliters of KOH. That is 0.1 molar. From our previous calculations, we know that the amount of mole of H3O plus initial, it's equal to the amount of OH minus that we added. So we're going to be at the equivalence point, which corresponds to a pH equal to 7, because we have complete neutralization. And finally, for D, we add 40 milliliters of KOH, 0.1 molar. This means that the amount of mole of OH minus added, it is going to be equal to 4 times 10 to the minus 3. The amount of H3O plus that we have at the beginning was 2 times 10 to the minus 3. So now the limiting reagent becomes the H3O plus. So we could go ahead and do another ice table, or we can simply subtract the amount of mole from one of the other. So the amount of OH minus that we are going to have after we have added all of it, it is going to be 4 times 10 to the minus 3 minus 2 times 10 to the minus 3, which is 2 times 10 to the minus 3. And now, for getting the final concentration, the final volume, it is going to be, we started with 20 milliliters, we added 40 milliliters, so this gives us 60 times 10 to the minus 3 liters, converting everything directly, or 6 times 10 to the minus 3. Okay, so our final concentration of OH minus in solution, it is going to be 2 times 10 to the minus 3 mole, this is mole, divided by 6 times 10 to the minus 2 liters. Which corresponds to, again, 0.033 molar. But careful here, this is of OH minus. So you may realize that that concentration is the same one as we found here, but now it is of OH minus. So if we calculate the POH, that is minus the logarithm of the concentration of OH minus, we're going to find 1.477. Now, we simply can use the relationship that pH plus POH, it is going to be equal to 14. Therefore, the pH at this point, it is going to be 14 minus POH, which was 1.47, giving us 15 point, sorry, 12.523. And that is going to be our pH for the last case.